Okay, before we start doing this video, this is my second video, I'm going to show you this. This is a page of notes, and this is one of the main things. If the p-value is less than alpha, you reject. If the p-value is greater than or equal to alpha, you do not reject. And then based on that, you go from there. Do you reject? You either reject or you don't reject. If the original claim contains equality, you go one way. If the original claim does not claim equality, you go a different way. So you got to check out how it's usually claimed. For the most part, we aren't using equal, but occasionally we will use it in the original claim. Most of our original claims we're using either greater than or less than, and occasionally we use equal, but then that's usually when we test the not equal, and that wording is slightly different. The main difference in the wording is the words support and warrant. I'll make this accessible to you and you can really read through it. And then I found these little tables that tell you how to use StatCrunch. These are the two main tests you're doing: stat, proportion stat, one sample with summary. And then you go from there. With the t-stats, you could probably have one sample you would have with data. Occasionally you have data. If you do, you have to copy it into the StatCrunch table and go from there. But I'll make this accessible to you. Okay, well, let's do this. This is, first of all, you want to see where they're actually getting their p-value from. You find a z and then the comparable p-value is what you're trying to do here. This is not the actual testing. You're conducting a study to see the accuracy rate for fingerprint identification is significantly less than 0.66. While H1, p is less than 0.66, you obtain a test statistic. Z is equal to negative 1.46. It says use a normal distribution calculator. Well, that means you go to stat, you go to calculator, and you go down to normal. Okay, this is your normal calculator. Less than, so you want to keep it with less than. What is it less than? 0.66. That's the setup, and it tells you to use a left tail. But this is the Z. Remember, this is on the Z scale. Standard, normal, 0 and 1. Put the Z value in here, negative 1.476, and then compute. P-values are usually 4 decimal places, especially if you're not told any differently. So this would be 0.0. That 7 rounds that 9 up to a 10, so that would be 0.700 when we round it off. One more than 699 is 700. Okay, same type of thing except what? This time we're doing a greater than. Okay, greater than 21. Our test statistic would be 2.268, and the p-value, very small p-value there, 0.011, and that would round to a 7. Okay, this one says not equal to. Well, when it's not equal to, that's a two-tail test, so we need to go to between. And between what? The two z values. It would be negative 1.254 and positive 1.254. Now, notice that is the area on the inside. We need to find what's in the two tails, not the middle, but the two tails. So I'm going to pull up Desmos. Wow, Thought I was going to pull up Desmos. And I'm going to have to do 1 minus whatever it was that was there. Sometimes you can copy and paste this stuff well, and sometimes it doesn't work too well for me. Okay. And so this is really one of the few times that you will actually have to use a regular calculator. 2.098. Okay. Okay, now you've got the complete test. So we don't need this anymore. We are using the actual testing. So this is what we want to do. We want to test. We are actually going to use, you see there's a P there, so that's proportion stats. We're talking about the proportion of something. We want 1 sample with summary. Okay, find the number of successes. Can you find it? 405. The number of observations, 723. P is equal to, change it to what's there, 0.62. This one does default to not equal to, and we compute. Our test statistic is the z-value, which is a -3 point, and I think they want 3 decimal places, 315 when we round it. The p-value, usually 4.0009, very low. That p is less than alpha. This is your alpha, 0.10. And see, this is like 0.000. So it's definitely, the p-value is less than. The p is less than, you reject the null hypothesis. And when you reject, okay, we kind of had to take a pause here. The test statistics leads to a decision to reject the null hypothesis, and there is sufficient evidence, but we aren't warranting a rejection. The sample data support the claim. They support the claim that this is true. So this is what we want to do. All right, there we go. Finally got it to take. All right, number 5, you're conducting a study to see if the proportion of men over 50 who regularly have their prostate examined is significantly less. Okay, that's your setup. We can delete that one. We go to stat. We want to go to proportion stat. We want 1 sample, and we want with summary. The number of successes, read for that. That's 226. The number of observations is 589. Sorry, working from home is tough. Okay. Our proportion is 0.41, so let's put that in. And we want the less than, and we want to compute. Your test statistic is the z, -1 point, and that would end up being, we want 3 decimal places, so that would be 298. The p-value is 0.0972. This p is pretty high, and that's your alpha. So p is greater than alpha. You want to fail to reject. When you fail to reject, there is not sufficient evidence to support the claim. Okay?